Hello, my dear students. Welcome back to our channel. We already discussed the inverse functions. Today, we are going to see derivatives of inverse functions. Derivative of a function at a point is nothing but slope of tangent at that point. So, in this video, we can see properties of derivative of a function and its inverse, or slope of tangent of a function and its inverse at a point. Okay, we can go to the video. Derivatives of inverses of differentiable function. We can start with an example of a straight line. Let f of x is equal to 1 by 2x plus 1. We know that equation of a straight line is y equal to mx plus c with the slope m and a y-intercept c. Here we can say slope is equal to 1 by 2 and y-intercept is equal to 1. Y-intercept equal to 1 means the line passes the y-axis at the point 1, or we can say 0, 1 is a point in this line. Then what is f inverse of x? F inverse of x we can see. We can write y equal to 1 by 2x plus 1, that is x by 2 plus 2 by 2, that is x plus 2 by 2, making the denominator 2 common. This is 2y equal to x plus 2. We can solve for x in terms of y. Then x is equal to 2y minus 2. Or we can say f inverse of x is equal to interchange x and y, 2x minus 2. So f inverse of x is 2x minus 2. What will be the derivative of this function? Derivative is nothing but a slope of this function, that is 1 by 2. We can see d by dx of f of x is equal to 1 by 2 into derivative of x is. Derivative of x is 1. So 1 by 2 plus derivative of 1 is 0. So derivative is 1 by 2. Here see the inverse of this function. F inverse of x is also a straight line in the form mx plus c with the slope m is equal to 2 and y-intercept minus 2. Or we can say 0 minus 2 is a point. Here see slope of the function f of x is 1 by 2 and slope of f inverse of x is 2. That is, they are reciprocal of one another. Here we can see d by dx of f inverse of x. D by dx of f inverse of x is nothing but slope of f inverse of x, that is 2. We can see d by dx of f inverse of x is d by dx of 2x minus 2. That is 2 into 1 minus 0, that is 2. So we can say derivatives are reciprocal of one another, or a derivative of a straight line and its inverse is reciprocal of one another. That is, slope is reciprocal of one another. Anything we can say. You can draw this graph simply. See, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 3, 4. See here, 0, 1 is a point. Y-intercept is 1, 0, 1 is a point. So we can mark 0, 1. Here in f inverse of x, 0 minus 2 is a point. So minus 2, 0 will be a point in f of x. We know that in f and f inverse, x coordinate and y coordinate get reversed. So minus 2, 0 will be a point in f of x. Minus 2, 0 is this. So we can draw the straight line, or we can find other points. Here substitute x is equal to 2. Then we get 1 plus 1. 2, 2 is a point. Here 2, 2 is a point. This is the line y equal to x by 2 plus 1. And its inverse is just a reflection in the line y equal to x. Reflection of f in the line y equal to x. It will be like here the point is 0 minus 2, 0 minus 2, 1 0 and 2 2. This will be like this. This is f inverse or 2x minus 2. Here our y equal to x line. Here say this line is non-horizontal or non-vertical. Horizontal means just like this straight line parallel to x-axis, and a vertical line means straight line parallel to y-axis. See, this is not a horizontal line nor a vertical line. We can say that reflecting a non-horizontal or non-vertical line across the line y equal to x. Here f inverse is the reflection of the line y equal to x by 2 plus 1 and the line y equal to x. So reflecting a non-horizontal or non-vertical line across the line y equal to x always inverts the line's slope. Here the line y equal to x by 2 plus 1 has the slope 1 by 2, and reflecting this line across the line y equal to x, we get the slope as 2. That is, the slope get inverted. So if a non-horizontal line or non-vertical line has the slope m not equal to 0, then its reflection across the line y equal to x has the slope 1 by m. So you may get why we are taking non-horizontal or non-vertical line. There we will get a slope is equal to 0. Then here 1 by m not defined. Here we have seen the reciprocal relation of slopes of a graph and its inverse in case of straight line, non-horizontal or non-vertical lines. This relation holds for other functions also. We can see. If we have a function y equal to f of x, what is the slope of this function? We can make a rough sketch. Let this be the function y equal to f of x. Slope of this function is nothing but slope of tangent at a point. Here if we take the pointer here, a f of a f of a, then tangent to the curve at a given point is the straight line that just touches the curve at that point. Here at this point we can say this is the tangent. Slope of this curve at this point is nothing but slope of this line, this tangent at this point. This is nothing but dy by dx at this point, a f of a. Slope of the tangent is dy by dx at x is equal to a. So slope of this function at a f of a, we can say dy by dx at x is equal to a. That is f dash of x at a. That is f dash of a. If slope of this function y equal to f of x is f dash of a and is not equal to 0, then we can say slope of y equal to f inverse of x at the point f of a will be 1 by f dash of a. So if slope of a function y equal to f of x at the point a f of a is equal to f dash of a and it is not equal to 0, then the slope of the function y equal to f inverse of x at f of a equal to 1 by f dash of a. That is, slopes are reciprocal of one another. Slope of a function and its inverse is reciprocal of one another. Slope of this function f inverse of x is nothing but derivative of f inverse at x is equal to f of a. We can say df inverse by dx at x is equal to f of a. So we can say derivative of f inverse at f of a equals the reciprocal of derivative of f at a. This is derivative of f at a. What is the graph of inverse of this function? If this is the point f of a and this is the point a, we can say the graph will be like this. Okay, this is the point f of a, f inverse of x. Next, we are going to discuss this theorem. The theorem is nothing but derivative of f inverse at x is equal to f of a is equal to 1 by derivative of f at x is equal to a. Don't forget, this is nothing but a slope of tangent of f inverse at the point f of a. I'm not making you more confusion. We can directly go to the theorem. So the theorem, the derivative rule for inverses. If f is differentiable at every point of an interval I and df by dx is never 0 on I, then f inverse is differentiable at every point of the interval f of I. The value of df inverse by dx at any particular point f of a is a reciprocal of the value of df by dx at a. That is df inverse by dx at x is equal to f of a is equal to 1 by df by dx at x is equal to a. Here some conditions. That conditions are just readable. To find the derivative of f should be differentiable. That is the first condition. Here we need 1 by df by dx. Then to see 1 by df by dx should be non-zero. That is the second condition. That is, if f is differentiable at every point of an interval I and df by dx is never 0 on I, then f inverse is differentiable at every point of f of I, and the value of df inverse by dx at any particular point x is equal to f of a is equal to 1 by df by dx at x is equal to a. Very simple theorem. In short, we can write instead of df by dx f inverse dash. F inverse dash is equal to 1 by f dash. Next, we can see examples. Then it will be more clear to you. Example, consider the function f of x is equal to x square, x greater than or equal to 0. X greater than or equal to 0, then only this function is 1, 1 and it has an inverse. Then its inverse is f inverse of x is equal to root x. We can find d by dx of f and f inverse. D by dx of f of x is equal to d by dx of x square, that is 2x. And d by dx of f inverse of x is equal to d by dx of root x, that is 1 by 2 root x. Next, we can consider the point 2, 4 in f of x. Then this point will become 4, 2 in f inverse of x. 4, 2 is the mirror image of 2, 4 at the line y equal to x. Then what is this derivative at this point? At 2, 4, df by dx is equal to 2 into, here x coordinate is 2. 2 into 2 is 4. And what is this derivative at 4, 2? Here at 4, 2, this become 1 by 2 into, here x coordinate is 4. Root 4, that is, root 4 is 2, that is 1 by 4. See, here the derivative is 4, here the derivative is 1 by 4. This is nothing but 1 by df by dx at x is equal to 2. Next example, let f of x is equal to x cube minus 2. Find the value of df inverse by dx at x is equal to 6. Find df inverse by dx at x is equal to 6 is equal to f of 2. Given 6 is f of 2. Without finding the formula for f inverse of x. Here we have to find df inverse by dx at x is equal to f of 2, 6. No need to find f inverse. Here see, f of x is equal to x cube minus 2. Then df by dx is equal to d by dx of x cube minus 2. D by dx of x cube is 3x square. And d by dx of 2 is 0. So this is 3x square at f of 2. That is, here the point is 6, 2. So here this point will be 2, 6. So at 2, this will become 3 into 2 square, 4, which is equal to 12. So df inverse by dx is equal to 1 by, we can write df inverse by dx is equal to 1 by df by dx at x is equal to a. Here at x is equal to f of a. So at f of 2, this will be equal to 1 by df by dx at x is equal to 2. That is 12, 1 by 12. Here we haven't defined f inverse, but we get the slope of f inverse, or we get the derivative of f inverse at x is equal to f of 2 without finding f inverse. We can discuss more exercises about this in the next video. If you find this video helpful, please don't forget to like, share, comment and subscribe. Thank you for watching. Thank you.